All right, so for this lesson, we're going to be talking about composition of functions. It's called composition because you're going to take one function and compose a new function by plugging it into another. So you're looking at one of the key things that you are going to analyze and look at is this open circle in between the f and the g. That open circle does not mean multiply, so we've done the operation of functions, and we talked about the closed circle means to multiply. We're going to be looking at that open circle, which means it stands for of. So we're going to take this and we're going to compose two functions, one inside of another. So the question is how do you read these two functions? So you actually are going to work your way backwards when you read this. So when I look at my problem, we're going to do f of g of x is how you read that. So f of g of x. But you're going to plug in whatever is in that outside parentheses into the g function, and then you're going to get your value, and then you're going to plug that value into the f function. So you work your way from the inside out. Now, there may not always be a number there. More than likely, we're not going to be doing much with the input of a number. We're going to get out actual expressions. So when we are looking, we're going to start with the x. And that x, if there's already an x there, then you don't have to do anything. You already have the x value in the problem. So we would take x, plug it into g. Then we're going to take whatever we get with that, and we're going to plug that into f. And we're going to get that composition. We're going to compose a new function using two others. So we're actually going to look at this and plug in our values. So we have an f function, we have a g function, and we have an h function. So this first problem says that we're going to compose f of g. So if I were to actually write this out, that means that we're going to take the g function and we're going to plug the g function into the f function. Okay? Now, the x is already part of the input value, so we don't have to actually plug in x because x is already there. So when I'm looking at this, we're going to start with what function are we going to plug into? So we're going to plug into the f function. So what I like to do is I like to take that function and I like to create placeholders. So everywhere I see an x, I'm going to take x out and I'm going to put in a parentheses. That is going to create a placeholder for me so I know exactly where I'm plugging in my g function. So I have negative 4x plus 3. So now I have negative 4 parentheses plus 3. And in that parentheses, I'm going to plug in my g function. My g function is 5x squared plus 7x minus 2. And then we're just going to evaluate and simplify. So we're going to distribute my negative 4 to everything in the parentheses. That's going to give me negative 20x squared minus 28x plus 8. Now, do not forget to bring down that plus 3 that's outside of the parentheses. And then combine any like terms. So negative 20x squared minus 28x plus 11. And we've now composed a new function by plugging one function into another. All right, so the next one is telling me to do g of h. So that means that we're going to take the h function and we're going to plug the h function into the g function. So if I were to write this out, this would be g of h of x. So we're going to take the h and we're going to plug that h into the g. So we're going to start with the g function. Now this time when I look at the g function, I have two x's that I have to replace. So when I do my placeholders, so I'm going to do 5 parentheses, and now that x was squared, so it's going to be parentheses squared, plus 7 parentheses, because it's 7x, I'm going to take the x out, put in the parentheses, minus 2. And in that parentheses, I'm going to put in the h function. Now the h function is 3x minus 1. All right, so again, everywhere there was an x, I'm going to replace that with the actual h function. Now, this one's going to take a little bit more effort to simplify because I have a parentheses squared. So that parentheses squared means I need to write it twice. So it's the same thing as saying 3x minus 1 times 3x minus 1. Now, I'm going to box method that. Again, like I said in my previous videos, if you want to multiply and you understand to multiply every piece in one parentheses times every piece in another parentheses, by all means do that. So this is going to give me 9x squared. Then we have minus 3x, and plus 1. So when I bring this back together, I have 5. I have 9x squared. So I have negative 3x. The negative 3x is going to give me negative 6x plus 1. So I multiplied that 3x minus 1 squared out. I can also distribute the 7 to the other parentheses. So this is going to become plus 21x minus 7 minus 2. So now we've multiplied those pieces. We can distribute the 5 to the original parentheses. And that's going to become 45x squared minus 30x plus 5 plus 21x. And we can go ahead and do minus 7 and minus 2 to give me minus 9. And one last step is to combine my like terms. So I have 45x squared. So I have negative 30x and positive 21x. So negative 30 and positive 21, that's going to give me negative 9x. And then I have 5 and negative 9, which is going to give me minus 4. So again, this one did take a little bit more effort, but it took a little bit more effort because we had to multiply out the squared parentheses. So we had to multiply those two linear binomials together. All right, so then we have f of f. So f of f means that I'm going to take my f function and I'm going to plug it into my f function. You're still going to compose the two, this problem. The key is that you're going to plug the same function into that problem. So I'm going to start with my f function. So remember, my f function was negative 4x plus 3. So I'm going to do negative 4x. We're going to take the x out, put the parentheses, plus 3. And we're going to plug in the f function. The f function was negative 4x plus 3. So you're plugging the same function into itself. So I'm going to distribute. And this is going to become positive 16x minus 12 plus 3. And then 16x minus 9. All right, we could do more than one composition. We could plug in not just one function into another, we could plug in multiple functions into each other. So this one is telling me to take f, plug it into h, then take h and plug it into f. So that means that we're going to have to start with the innermost problem. So we're going to have to do this process twice. So we're going to start by doing the h of f of x. And then once I do the h of f of x, then I'll take that and plug that whole piece again into the f function. Because you got to break it up so that you can see all the pieces together. So I'm going to start with the h function. So we're going to do h of f first. So h of f, so h is 3x minus 1. So we're going to do 3. We're going to take the x out, put parentheses, minus 1. And we're going to plug in the f function. So the f function is going to be negative 4x plus 3. So we're going to simplify that. We're going to distribute. And that's going to give me negative 12x plus 9 minus 1. And then I have negative 12x plus 8. So we know that what's in yellow, the h of f of x is negative 12x plus 8. So we now need to finish this off by plugging that into the f function again. So if I go back to my original problem, so remember f is negative 4x plus 3. So we're now going to do f of h of f. So we've already done this part. This part right here equals this. We're going to take that and plug it into the f function. All right, so my f function was negative 4x. So where the x is, we're going to put our parentheses, plus 3. Let me make sure I got that right. So negative 4x plus 3. And we're going to plug in that h of f, which we found to be negative 12x plus 8. So I'm going to distribute. So that's going to give me a positive 48x minus 32 plus 3. And then my final answer here is going to be 48x minus 29. Okay? So you really are looking for the pattern. So you start from the inside and work your way backwards. Now, what happens if we're given a number? So I'm looking at this particular problem for K, and it's asking me to do h of g of 2. So there's two ways that we can handle this. One I feel is a little bit more simpler than the other, but I'll let you decide which works best. So the first one, you're going to take the function and you are going to plug in the function first. So you're going to forget about that 2 for a minute, and you're going to plug in that function first. So we're going to start by just doing this h of g. So I'm going to take my g and I'm going to plug that into h. Okay, so I'm going to start by getting my base, which is the h function. And I have 3x minus 1. So 3x, put the parentheses, minus 1. And we're going to plug in the g function. So remember, the g function was 5x squared minus 7x minus 1. I think it was mine. No, it's plus. So 5x squared plus 7x minus 1. And at that point, we would distribute. And I have 15x squared plus 21x minus 3. And then bring down my minus 1. So that's going to give me 15x squared plus 21x minus 2. Now, we have the function, so now we're going to go back and we're going to worry about that 2. We're going to take the 2, and we're now going to plug the 2 into the function. So everywhere I see an x, I'm going to plug in 2, and I'm going to evaluate. All right, so I've plugged in my 2 everywhere I see an x. And if I evaluate this, so I have 2 squared, that's going to give me 4. And then 4 times 15 is going to give me 60. And then I have 21 times 2, that's going to give me 42. So 50 and 42 is 92 minus 2, 60 and 42. All right, I feel like I missed a piece here. Let's see, where did I miss it? I think, did I plug in one piece wrong? I did. I did this in the last video too. Sorry, guys. So technically, I rewrote the problem wrong again. So this is going to be minus 2 here. So this would actually turn into minus 6. All right, and then that's going to turn into minus 7. All right, so when I look at it, I have 15, so that is going to be 60, 60. Then we have plus 42, so that's going to be 102. And then 102 minus 7 is going to give me a final total of 95. Now, how is this going to be different from the second method? Well, the second method is you plug in the number first. Now, what do I mean by plug in the number first? That means that we're going to start, and we're going to do it in 2 steps. We're going to take the 2, and we're going to plug the 2 into the g function, and then we're going to get a number, and we're going to take that number and plug it into the h function. So if we start this, I'm going to start by finding g of 2. So my g function is 5x squared, so we're going to do 2 squared, plus 7 times 2 minus 2. All right, so remember, so just a reminder, g function is 5x squared plus 7x minus 2. And once you get this, you get that it equals 32. Now, we're going to take 32 and we're going to plug that into the h function. So we're doing 2 steps here. So my h function was 3x minus 1. So 3x minus 1. And here we're going to plug in 32, which comes out to equal 95. Same answer, just 2 different ways of processing that. I think that plugging in the number in 2 steps is sometimes easier. It kind of depends on how the functions are laid out, especially if you're having to multiply. like we did up here with the box. If you're having to do that, then it can become a tedious process. Again, it's completely up to you how you choose to do it. So I'm going to do it again with my number first. So I'm going to plug -3 into h. So remember, h was 3x minus 1. So we're going to do 3. My x value is -3 minus 1. That's going to give me -10. All right, so now we're going to take the 10 and we're going to plug that into f. So we're going to do f of -10. And f was -4x plus 3. So -4x is going to be -10 plus 3. And that's going to equal 43 is my final answer. All right, so here's some options as well. We talked about Desmos the last lesson we did with operations. All right, so if I pull this up, we can do the same thing with composition. So let's go back and let's look. So let's look at the first one. So we have to label it. You make sure you label it properly. So we have f of x, and we have f of x is -4x plus 3. And we have g of x is going to be equal to 5x squared plus 7x minus 2. Now remember, we don't need to see the graphs individually, so we're going to turn those off. What I want to find is the composition. Now you have to type it such that you are plugging with the parentheses. If you don't type it that way, there's no way to do the of. The only way it's going to understand the composition is if you use parentheses. So you're going to do f parentheses of g, which is parentheses of x. And there's my function. So there's what you should get if you did the composition, the graph. Well, we got -20x squared minus 28x plus 11. And again, if you did it right, they should match each other. All right, so if I turn them on and off, I should see that they are identical. All right, it works the same way with, like if we do m here. So this is the same thing as g of f of 1, okay? So if I were to take my f and g function, it'll actually give me the numerical value. So I have g parentheses f of 1. And we get that the answer is -4. Okay? So if I did this and I worked it out, so f of 1 is going to be -4. We're going to plug in that 1 into the f function. And we get -4 plus 3, so that's going to give me -1. Now we're going to take the -1 and plug into the g function. So my g function is 5 -1 squared plus 7 times -1 minus 2. And if you work that out, I mean, if you want to plug it in right here, you can into Desmos, and you can use Desmos as a actual calculator as well, not just graphing. Minus 2. And we also get -4, which is what we got when we did it with Desmos. So it's a way to check yourself and to see if you got it correct. All right, so I do have a few more examples. I think we've done quite a bit of them, but I did want to show you, I'm going to edit this function right here so that it says g of x is equal to the square root of x minus 4. Now, when I'm looking at this, they're asking us to find, we're going to find f of g. Okay, so that means we're going to take the g function and we're going to plug the g function into the f function. So my g function is the square root of x minus 4, and we're going to plug it into the f function. So the f function is x squared plus 1, so we're going to do parentheses squared plus 1. And we're going to plug in that g function because we're plugging the g into f. So this is the square root of x minus 4. So if I square a square root, those are inverses of each other, so I'm left with x minus 4 plus 1, which is just going to be x minus 3. All right. Let's see. All right, let's do the first example on this side. So they're asking us to do g into f. So we're going to take the g function and plug it into the f function. So again, parentheses squared plus 1. And we're going to plug in the g function, which is x squared plus 5. Now remember, when we have that parentheses, that means that we're writing it twice. So we're doing x squared plus 5 times x squared plus 5. I'm going to do my box. So we have x squared and 5, x squared and 5. So this is going to be x to the 4th, 5x squared, 5x squared, and 25. So I'm going to bring that all together, and we get x to the 4th plus 10x squared plus 25 plus 1. And finally combine like terms, and we get x to the 4th plus 10x squared plus 26. All right, and our last option. So we did number 11, we used those. I'm going to, let's see, I'm going to rewrite these on the bottom so we don't get confused. So I have 2x minus 10, and we originally had g of x, which is going to be x minus 4. I want to find f of g of g. So remember, that means we're going to take the g, plug it into the g function, and then get an output, and then take that and plug it into the f function. So we're going to start by finding g of g. So g of g means I'm going to take the g function and plug into the g function. So the g function is x, so we're going to put parentheses minus 4. And we're going to actually input that g function, which is going to be x minus 4 again. So this is going to turn into x minus 8. So now we're going to take that x minus 8, and we're going to take that and plug it into the f function. So we're going to do f of g. And again, we've already done the g of g. We're going to take the g of g and plug into f. So the f function was 2x. So we're going to put our parentheses for our placeholder, minus 10. And we're going to plug in x minus 8 and simplify. So that's going to be 2x minus 16 minus 10, which is going to be 2x minus 26. Now, if you have any questions about this, or you feel like you're struggling with the multiplication, please let me know. I'll be more than happy to help you. And always check yourself and